Alright, this is exercise video number 28, and for my exercise today, I did leg day and then ran a mile outside. So I did some Bulgarian split squats, leg extensions, lunges, and leg press, and then some calf raises as well. And then after that I stretched, and then I went outside and ran 1 mile. And so to relate this activity to what we're learning right now in XPhys, whenever I, for example, was doing the Bulgarian split squats, my legs were hurting really bad, and it was really hard to keep the weight going and to keep that work rate up. And this is because whenever that muscle contracts, ATP releases phosphate and then also produces hydrogen. Whenever you're breaking down ATP to ADP and phosphate, you're releasing a hydrogen, and that hydrogen builds up in your muscle through that contraction, and that hydrogen denatures the protein in your muscle, and ultimately your muscle isn't able to forcibly contract the way that it should be able to. And that is why I was experiencing that breakdown of form and I wasn't able to keep that work rate up. That is because of the buildup of hydrogen ions. And also whenever pyruvate is converted into lactate, you get hydrogen, and also going from pyruvate to acetyl-CoA, you get carbon dioxide, which has the potential to turn into carbonic acid, which is an acid, and you could get a hydrogen from that. And so in order to buffer against these hydrogen ions, I have the sodium bicarbonate buffer system, and also have dipeptides, proteins, MCT, the sodium hydrogen exchanger, and phosphates. And so for the MCTs, for example, those are going to kick out lactate and hydrogen at the same time. And then I've got the sodium hydrogen exchanger, which brings sodium in and take out hydrogen from my muscle. And then also the dipeptides, for example, carnosine is going to be the most abundant of that one. And carnosine, you need beta-alanine to form carnosine, because beta-alanine combines with histidine, and carnosine buffers against those hydrogen ions as well. They're kind of like the sacrificial lambs that are like your first line of defense against those hydrogen ions. And then we have the sodium bicarbonate buffer system, which is going to be the most important. And so whenever I'm producing that CO2 going from pyruvate to acetyl-CoA, that CO2 is dissolved in water and forms carbonic acid via carbonic anhydrase. And then from carbonic acid, it's broken down into bicarbonate and hydrogen. That hydrogen goes onto hemoglobin and turns it into deoxyhemoglobin, kicking that oxygen off into my muscle so that I'm able to use that oxygen. And so whenever I was doing doing lunges or the Bulgarian split squats or whatever it may be, I was working out my quads mainly, maybe a little bit of my gastroc as well, and those muscles in my hamstrings, just my leg muscles for the most part. And so my upper extremity vasoconstricted, and like, for example, my intestines, my any muscle pretty much that wasn't needing oxygen for that exercise vasoconstricted in order for my working muscle to get the most oxygen in order to keep up with that work rate.